Today you should start by picking up a note packet for the last unit of the trimester. As a warm-up, you guys should have discussed what you remember about lab safety. Safety reminders make sure you can perform lab safely and follow all lab safety protocols. We went over these safety reminders in class, so I'm not going to go over them again, but make sure you review them as needed. Today we're going to focus on density. So your learning targets are, I can define density and I can determine which object has more density. So what is density? Density is the compactness of a substance. Density depends on how much mass a substance has. Density also depends on how much volume, or space, a substance takes up. The equation to calculate density is equal to mass divided by volume. The unit for density is G/cc, which stands for grams per centimeters cubed, or another unit is G/ml, which is grams per milliliter. The larger the number, the more dense. So the higher your density number, the more dense your object is. If the density of water is 1.00 G/ml, and you put a cork with a density of 0.24 G/cc in water, will it sink or float, and why? So remember, we're going to take a look at these two numbers. The larger the number, the more dense it is. So will a cork sink or float? A cork will float. And why will it float? Because the density of the cork is less than the density of water. The 0.24 is less than water, so it will float. Let's take a look at another example. If the density of water is 1.00 G/ml, and you put a rock with a density of 2.74 grams per cc in water, will it sink or float? So again, take a look at those numbers, 1 and 2.74. So will it sink or float? It will sink, because the larger the number, the more dense it is. So sink because the density of the rock is greater than the density of water. So again, if we compare those two numbers, 2.74 is greater than 1.00, so the rock will sink. What about if we look at density with particles? Mass, which you can remember that density is dependent upon, mass will be represented by the number of particles. Density is also dependent on volume, and volume will be represented by the size of the box. So without numbers and just looking at a diagram, density will be how close together the particles are. So for example, you don't need to write these down. Just take a look at them. All right, so in our first box over here, if I look at the mass is defined as the number of particles. So I'm just going to count how many there are. 1, 2, 3, 4, 5. All right, if I take a look at the mass of our second box, again, it's just the number of particles, so count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so mass is just counting up how many you have in there. Volume. Volume is the size of the box, and we're just going to be comparing the volumes of these boxes. So if we look at the volume, they are about equal to each other. All right, and then we have the density, which is how close together the particles are. So if we look at the density of each of these, which box looks like the particles are closer together? This second box. So the second box is going to have a greater density. Let's take a look at one more that you do not need to write down. All right, so again, we've got box 1 and box 2. Take a look at the mass in box 1. How many particles are there? We have 5. How many particles do we have in the second one? We have 5 again. If we take a look at the volume, remember the volume is just the size of the box. Which volume is bigger? So our first box has a greater volume because the size of the box is bigger. And if we take a look at our density, okay, remember that density is how close together your particles are. Which box has the particles closer together? The box on the right has more. Okay, so let's take a look at a couple examples that you will write down for. So we have these two boxes. Let's do the same process. So first determine the mass. Remember that mass is defined as the number of particles. So just count how many particles are in that box. 1, 2, 3, 4, 5. Okay, let's do the mass for the second box. Again, it's the number of particles, so let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so who has a greater mass? The first box or the second box? The second box. Now let's take a look at the volume. If we take a look at these two squares, remember that the volume is just the size of your object, how much space it takes up. So if we take a look at it, the volumes of these two items are equal. So now let's take a look at the density. Okay, remember that density is represented by how close together your particles are. So which box, the first box or the second box, has the particles closer together? The second box. So the density is greater for the second box. Another way to look at that, right, you have the same volume, but box 2 has more mass, so it has more density. Let's try one last example. Why don't you start this one on your own? All right, let's take a look and compare them. So what was the first step? Our first step is to figure out the mass. All right, remember that mass is determined by the number of particles. So we have 5, and mass is equal to 5 again. So these two masses are equal to each other. Next thing to take a look at is your volume. Remember that the volume is the size of the box. So which box is bigger? Your second one. And now let's take a look at the density. Remember that density is determined by which box has the particles closer together. So which box has more density? Box 1. Okay, so another way to look at that is you've got the same mass this time, okay, but box 1 has a smaller volume, so it is more dense. It is more tightly packed together. So what should you do next? You have the density column lab, so you'll need your packet, grab the lab materials from the teacher, and a pair of goggles. Yes, you must wear goggles the entire time and follow the lab safety protocols. Read all the directions before beginning and complete your worksheet in the packet. After that, complete the lab conclusion on Schoology. Again, use your packet to help you with that. And then you can complete the density practice on Schoology. Homework for today if you did not finish the density screencast.